Morning students. Today we will discuss diffusion principles in biological systems. This is the topic covered in unit 1 of your syllabus. Now what is diffusion? Diffusion is defined as a mass transfer of individual molecules of a substance caused by random molecular motion and associated with a driving force such as concentration gradient. Means simply you can say that diffusion is the movement of molecules of a substance across the membrane from a region of high concentration to the region of low concentration under the influence of the concentration gradient. Diffusion is a time-dependent process. The movement is based on the kinetic energy, velocity, the charge and the mass of the molecules. The number of drugs are absorbed by the passive diffusion process. There are various types of diffusions. Number 1 is passive diffusion. Passive diffusion is the movement of the molecules from the region of high concentration to the region of low concentration. This process is passive diffusion process. The difference between high and low concentration is termed as concentration gradient. Diffusion will continue until the gradient has been eliminated. Simply you can say that passive diffusion is the movement of molecules from the region of high concentration to the region of low concentration. Next is facilitated diffusion. It is the movement of molecules across the cell membrane via special transport proteins that are embedded within the cellular membrane. Means you can say that it is the movement of molecules across the cell membrane via special transport proteins that are embedded within the cellular membrane, that are present in the cellular membrane. Third type is active transport. Active transport process means movement of molecules across the cell membrane from a region of low concentration to a region of high concentration against the concentration gradient. You can see in the diagram. Next type is filtration. Filtration is the movement of solvent or solute molecules influenced by the hydraulic pressure. So we have discussed various types of diffusions, that are passive diffusion, facilitated diffusion, active transport and filtration. Now we will discuss the diffusion process. I have already told you students that diffusion process is the movement of the molecules from the region of high concentration to the region of low concentration under the influence of the diffusion coefficient or concentration gradient. The diffusion phenomena applied in pharmaceutical sciences includes the release of drug from dosage form is diffusion dependent, estimation of molecular weight of polymers, prediction of absorption and elimination of drug molecules in living system. Now there are various laws of diffusion. First law is Fick's law of diffusion, which was given by Adolf Fick. So that's why it's called as Fick's law. It is the first law given by Fick. It states that the diffusion flux is directly proportional to the concentration gradient. Means diffusion occurs in response to a concentration gradient expressed as given by the equation J is equal to minus D dC upon dx, where J is the diffusion flux, D is the diffusion coefficient of penetrant, dC upon dx. Here dC is the change in the concentration of material, dx is the change in the distance. Now this is the graph which shows the Fick's first law. The flux is rate of mass transfer through a unit cross section of barrier in unit time. J means flux, diffusion flux, which can be given by the equation J is equal to dm upon s dt. Okay, where dm is the change in mass of material, s is the barrier surface area, dt is the change in the time. Now second is the Fick's second law. Fick's has given two laws, first law and second law. The second law states that the change in concentration with time at a definite location in a unit time is directly proportional to the concentration gradient at that time. Okay, it is an equation for the mass transport that emphasizes the change in concentration with time at a definite location in a unit time. It is called as Fick's second law. It can be given by the equation dc upon dt is equal to minus dj upon dx, which can be given as d square c upon dx square. Okay, Fick's first law gives the flux in the steady state of flow, and the Fick's second law refers in general to the change in concentration of diffusant with time at any distance. Okay, non-steady state means first law has given the flux in the steady state and second law has given the flux in the non-steady state of flow. The diffusion coefficient changes as the properties of system change. At higher temperature, the diffusion coefficient is larger because the molecules have more thermal movement. Okay. Next is steady state diffusion. Now, steady state diffusion. A system is said to be in the steady state if the mass transfer, that is dc upon dt, remain the constant with time. Okay, if condition vary with time, then the system is unsteady. Means two types of systems are there, steady system and unsteady system. Steady means if the mass transfer remain the constant. Unsteady means if the mass transfer varies with the time. Suppose there are two compartments separated by a semi-permeable membrane. Okay, consider the diffusion dissolve in the solvent in the left compartment. Means two compartments are there, that is left compartment and right compartment. Left compartment means donor compartment and right compartment is receptor compartment. These both are separated by a barrier. Okay, consider that the diffusant dissolved in the solvent in the left compartment of the chamber, that is donor. The solvent alone is placed on the right side of the barrier. Okay, that is the receptor. The solute or penetrant diffuses through a central barrier of the system to the solvent side. Okay, the diffusion process occur like this. Now, this is the diagram which shows the steady state diffusion. Okay, in diffusion experiment, the solution in the receptor compartment, you can see a receptor compartment in this diagram. Okay, the solution in the receptor compartment is constantly removed. Okay, and replaced with fresh solvent to keep the concentration at the low level. Okay, now this condition is called as sink condition. You can see in the diagram. Originally, the diffusion concentration will fall in the left compartment and rise in the right compartment. Okay, generally you can you know that when molecules will transfer from the left compartment to right compartment, then the concentration will fall in the left compartment and the concentration will rise in the right compartment. Okay, and the both systems comes in the equilibrium. After some time, the concentration of diffusant in the solution at the left and the right becomes constant. Okay, equilibrium condition exists. At that time, dc upon dt is equal to minus d square c upon dx square is equal to 0. Means both the conditions are in equilibrium on both the sides. Okay. Now, next topic we will discuss is measurement of diffusion. Students, how we can measure the diffusion? It can be measured by the Franz diffusion cell. Franz diffusion cell, you can see the diagram. This is the diagram of the Franz diffusion cell. You can see one donor compartment is there above, then receptor compartment is there. These two compartments are separated by the membrane. Okay. Now we will discuss the Franz diffusion cell, how it works. The Franz cell apparatus, it consists of the two chambers, as I have told you, that is donor compartment and receptor compartment. These both are separated by a membrane. Although membrane we can use animal skin membrane, okay, human skin membrane can also be used. The donor chamber consists of the known concentration of solute, means donor compartment consists of the solute, The receptor chamber contains fluid from which samples are taken at regular interval for analysis. Okay. The chamber is maintained at constant temperature, that is 37 degrees Celsius. When the experiment starts, the solute from the donor chamber, above chamber, the solute from the donor chamber, it diffuses through the membrane and it reaches to the receptor chamber. In receptor chamber, the solution is periodically removed for analysis via sampling port. You can see sampling port. With the help of sampling port, we remove the solution for analysis. The test determine amount of diffusion that has permeated the membrane at each time point. Okay, the solution of receptor chamber is replaced with a new solution after each sampling. By this method, we can measure the process of diffusion. That's all for today. Thank you.